Here's the picture for chapter 3, for the beginning of chapter 3. So the first 4 problems on this test are taken from this picture. So let's take a look at the first ones. It says, identify each pair of, and they list them for you, so it's nice. You don't have to memorize all these. They say list them as either alternate interior, alternate exterior, corresponding, or consecutive interiors. So they actually put the words there. You know what would be really nice, too? If you spelled it right. You know, because it is written right there on the test. I don't mark it wrong, okay? I won't mark it wrong if you don't spell it right. But look, it's right in front of you, all right? So spell it correctly. That'd be really nice. Just a pet peeve, that's all, okay? So let's do this. So number 1 says angle 5 and angle 13. I won't write it down. We'll just look at it. So angle 5 and 13. Let me circle it. 5 and 13. And you have to tell what they are. What is the relationship between these angles right there? Are they alternate interior angles? No. If you look at it, these would be your 2 lines. This would be your transversal right here. They're not alternate interior. They're basically in the same spot. If I took a look at these 4 angles here and these 4 angles here, this 5 is in the same place as this 13, isn't it? It's in the top right, top right. So if they're in the same place, what do we call those type of angles out of that list of 4? What's that? No, they're not consecutive. If they match up with each other, they're called corresponding angles. All right, guys? So these are corresponding angles, right? This is in the top right of this group of 4. This is in the top right of this group of 4. They match up with each other. So they're called corresponding angles. So make sure you know what those names are. Now the next one is 9 and 16. So let's take a look at 9 and look at 16. Now this time, this is your transversal, and these 2 are your lines. And they're not necessarily parallel lines, but they are 2 lines cut by transversal. So look at this angle 9 and this angle 16 right here. Look, they're on opposite sides of the transversal, and they're on the outside of those 2 lines. You see it? So they're alternate, right, because they're completely opposite each other, and they're exterior angles. They're on the outside, so obviously what? Alternate exterior angles. Make sense? All right. What if, now this is not on the test, but what if I said 10 and 15? What would 10 and 15 be? They're alternate, right, because they're on opposite sides of the transversal. One's up here, one's down here, and they're in between the 2 lines. In between the 2 lines. That means they're interior angles. So make sure that you know those. All right, so that's 1 and 2. Let's take a look at 3. This is where I have to think a little bit. Now they say, on number 3, it says, given that A and B are parallel to each other. So at first we didn't know they were parallel, but now we do. So we'll put a little arrow here and a little arrow here. So these 2 lines are parallel to each other. And it says angle 6 is 89 degrees. So let's just do this. So this is 89 degrees. That's angle 6. And the question says find angle 10. Find angle 10, that angle right there. Well, you got to look at the relationship. Look at the relationship between these. Now, we do have parallel lines cut by transversal. Now, they don't ask you the name of these things, so you don't really have to know the name of them. But what would the name of these be if I asked you? What's that? You got to wait till he comes back. So they're what? Consecutive interior angles, aren't they? And what's true about consecutive interior angles with parallel lines? They add to 180. They're supplementary, aren't they? So what's the math involved to solve for angle 10? It's 180 minus 89, and that's what, 91? Is that right? 91? Okay. So that angle right there would be 91 degrees. We all right with that? All right. That was pretty easy. The math wasn't hard. It's understanding what they are. Understanding, are they equal to each other? Now look at it. Just looking at it, would they be equal to each other? Look at this angle. This is an acute angle, isn't it? Look at this angle right here. What kind of an angle is that? That's an obtuse angle, so there's no way they're going to be equal to each other. So don't just sit there and take the easy way out and say, oh, they're probably equal. No, look at them and decide what they are. So if they're not equal to each other, then they're going to be supplementary, all right, if you have parallel lines cut by transversal. Everybody got that? So that's kind of a nice, easy way to figure that out, all right? So let's move on and do the next one. And let's replace this with This was, what, 6? All right, let's try this again. Number 4. I'll write this one down. It says angle 8 is equal to 4x plus 10. And it says angle 12, I'll just list them down here like this, is equal to 7x minus 7. And then angle 11 is equal to 3y. And you have to solve for x and y. All right, let's go a different color on this. Let's go orange. All right, let's put those in here. So this angle 8 is 4x plus 10. So this is 4x plus 10 degrees. Then it says angle 12. So I'm going to go down here and get rid of that 12 and make that 7x minus 7 degrees. So 7x minus 7 degrees. And then angle 11. Let's take 11 and change that. Let's change colors first of all and make it 3y. And that's degrees as well. All right, so let's take a look. And this is the information we're given. We still know that these two lines are parallel to each other, A and B. All right, we still know that. Let's scooch this up a little bit. And we got to solve for x, we got to solve for y. So if you look at it, I've got the two x's here. What's the relationship between this angle here and this angle down in here? Are they equal to each other? You only have two possibilities. They're either equal to each other or they're supplementary. Okay, are they equal to each other? Obviously not. Look how little that angle is. That's a little acute angle, and this is a big old obtuse angle. They're not equal to each other, so they must be what? They must be supplementary to each other. So in order to be supplementary, what do we do to them? We add them up and set them equal to 180. And now we just solve for x. Let's do this really quick. That's 11x. When I add the x's together, that's a plus 3, and that's equal to 180. Subtract 3 from both sides, so that's 177. Divide by 11, and, oh, I think that doesn't come out very pretty, does it? It's 177 divided by 11. So we'll round it to one place, so it's 16, we'll say 16.1, all right? So x is 16.1, so that's what x is equal to. Didn't come out to a nice pretty answer, but it does come out to a decimal answer. We'll just leave it as a decimal. Everybody with me so far? That wasn't too hard. You have to wait. Somebody's out. So look at these two angles right here. These two angles are supplementary. We solve for x, but now what we have to do is we got to solve for y. Now if you look at this angle right here, this 3y, you could say it's supplementary to this angle right here, okay? Or you could say it's equal to this angle right here. Everybody see that? Because what's true about this angle right here and this angle right here? They're equal because they're alternate interior angles. Very good. All right. The problem is I don't really know what that angle is, but I could figure it out, couldn't I? How could we figure out what that angle is? Plug it in. That's right. Take the 16.1, plug it in for this x right here, and figure out what this angle is. Well, calculator would be helpful here. So it's 4 times 16.1. Let's turn it on again. So it's 4 times 16.1. Whoops. Let's try 1. There we go. 16.1. And then what do? Add a 10. Why do I keep hitting 4 there? Don't know why. It's a 1. All right, and hit that, and it's 74.4. So this angle right here is 74.4. Is that what our answer is? Is that what y is equal to? No, it's not equal to that. This 74.4 degrees is equal to 3y. So 3y is equal to 74.4. Now, to solve for y, we've got to do one little quick thing. Divide by 3. So we can take this 74.4 divided by 3, and that's 24.8. And that's your answer. So y is 24.8. So that was a little bit more involved than what we did before, but you kind of started off really easy and then got a little bit tougher until you got to this. All right. Came out to a little bit of an ugly answer, but look, with the help of a calculator, it wasn't that bad at all. All right. I would not keep this as a fraction. I would not keep this 177 over 11. Let's listen, please. So I would not keep this as a fraction. I would definitely put it into a decimal, then plug it in. and then you're good to go. All right? That's that. Let's move on to something that's really a lot different than that. And this is number 5. This is where some of you guys really need to start paying attention, because this is the beginning of where it got a little bit tougher. All right, I think this part 5, 6, and 7 are pretty easy, but it's really going to help set the table for what we're going to do a little bit later. So they give you 2 points. They label the points. I don't really think we need to label the points. I'll just put the points down. And they ask for the slope. It says find the slope. So you need to find the slope. I haven't done this yet, so I got to remember to do this before you guys take the test. But I'll probably give you a like a formula sheet or something like that, and I probably will even write this on there. Okay, what the slope is. I really shouldn't. It was suggested to me by somebody that we do this, and so I'm taking the suggestion. All right. As much as it bothers me, I'm still going to do it. All right. So how do you find the slope? It's remember this, the change in y over the change in x. What does it mean to the change in? It means we subtract them, right? And then we subtract the x's, right? Cleo, please. So look at this right here. This is our formula. You need to know how to use the formula. I'll probably give it to you on some formula sheet, but you need to know how to use it. So find the slope. Remember, m stands for slope. And what do? We subtract the we subtract the y's, we put it on top, subtract the x's, and we put it on the bottom. So let's do the y's first. You got to realize which ones are the y's. Hopefully, at this point, you realize which ones are the y's, or the second one. So I go 11 minus 7. Now, somebody yesterday asked me, does it matter what order? Couldn't I go 7 minus 11? Yeah, you could, but you got to go in that order with the x's if you do that order in the y's. To me, I think it's easier just taking the first one minus the second one and doing it that way every single time. So I've got 11 minus 7, and then on the bottom, I've got negative 5 minus 5. See that? I went the first x minus the second x, and I went the first y minus the second y. Hopefully that makes sense. And now you just work this thing out. 11 minus 7 is 4. Negative 5 minus 5 is negative 10. And you reduce it. Always reduce. So let's see, 2 goes into that twice, 2 goes into that 5 times, so it's negative 2/5. And that's your answer. So you must, I'm going to write this down so you can't say, well, you didn't tell me. All right, you must reduce your fractions. You must reduce. Everybody understand that? It's right there. I was going to say in black and white, but it's black and yellow. It's right there in black and yellow. All right, so you must reduce your fractions. So that is the only acceptable answer right there. Don't change it to a decimal. Don't want it as a decimal, okay? Slopes don't really make a whole lot of sense as decimals. I want to see a rise and a run. I want to see a fraction. Hopefully that makes sense to you. All right. Let's go to a different color here. Watch number 6. Number 6 is pretty much the same thing, except the answer looks a little different. And I put this on this test for a particular reason. I put 6 and 7 on there because I want you to understand not just how to find the slope. I could have just done one problem and see if you knew how to find the slope. It's understanding what this type of slope actually is. So let's do the math really quick. It's negative 2 minus negative 2. What's minus a negative? It's plus. And then we do the y's. So it's 3 minus 12. Now look what we get. Negative 2 plus 2 is 0. 3 minus 12 is negative 9. I don't just leave it 0 over negative 9. Right? What is, you could do this on a calculator. If you have a calculator, put that in a calculator. What is 0 divided by negative 9? It's 0. It's 0. The answer is 0. It's not no slope. It's not undefined. I actually was very, very easy on you guys when you took the test. But we've gone over this a second time now, and I've written it. I wrote it on your paper. A lot of people wrote just 0 over negative 9. Some people actually wrote undefined on here. And technically, I should mark that wrong. And I don't know if I did or not. I think if I saw this, I gave it to you. But I was being very, very lenient back then. Right now, I'm not going to. If you write undefined, I'm going to mark it wrong. If you only write 0 over negative 9, I'm going to mark it wrong. Why? Because I told you must do what? You must reduce it. You must simplify. This is the only acceptable answer right there. Everybody hear me? In fact, I'll even get rid of this circle here so you don't think you can use that. This is the only acceptable answer that I'm going to accept if I have a question like this on the test. It's a zero slope. What kind of line is it if it's a zero slope? Remember going skiing, you go 0 miles per hour, what are you on? You're on a flat surface, right? You're horizontal. It's horizontal. That's a horizontal line with a zero slope. That's something that you should remember. You're going to be drilled with that stuff in Algebra 2. All right, so I hope you remember it now so that when you get to Algebra 2, it'll be right there in your mind. In fact, Mr. Smith teaches an Algebra 1 class the period before you guys come in, and it's my planning period, so I'm at the desk, and he's actually teaching, he was talking about that today, about horizontal, zero slope, and undefined slope, and all that kind of stuff, and that was Algebra 1. So that means you learned it in Algebra 1, you definitely learned it in here, at least I taught it to you in here, and you're definitely going to use it next year in Algebra 2. So it's something that if you're going to have it all that time, it's something that is very important that you should need to know how to do. All right, let's keep going. Number 7. Let's put the points here. So I've got 8, 6, and I've got 8, negative 4. All right, so let's do this, and we're finding the slope again with this stuff. Slope is a very important thing to find, not just in math class, but in other classes. For instance, I taught physics for quite a few years. Finding the slope of a line was very, very important. I know in chemistry, even biology, sometimes finding the slope of a line. If you have data points, you do an experiment, you want to find the slope of the line that those data points make, that tells you something specific about your experiment, about what you're trying to do. So the slope is a very important thing. So we're learning it now, and you probably have no idea why in the world you would ever want to use to find the slope. But the slope is something that's very important that we will use, that you will use later on in your science classes. Okay, even for history and things like that, you might have to plot data points. I don't know. You probably don't do it too much in history, but you do it in science quite a bit. So here we go. Let's do this. Subtract the y's, right? So it's 6 minus negative 4. And then subtract the x's. Put it on the bottom. It's 8 minus 8. 6 minus negative 4 is the same as 6 plus 4, which is a 10, over 8 minus 8, which is 0. Don't leave it like this. If I put this in a calculator, Brianna, put that in your calculator real quick. Put 10 divided by 0. What do you get? It says error, doesn't it? Now, you don't write the word error on here. What do we write if it comes out to an error on the calculator? You say it's undefined. Okay, now there's a couple options that you could say. Undefined is a great option. You could just say undefined, and that would be your answer. Do not say it's 0. Is 10 divided by 0 0? No, it's not. Okay, it's not 0. It's a completely different looking line. Remember, what kind of a line is a zero slope? It's a horizontal line. What kind of a line is an undefined slope? Remember we had the story about me rappelling, right? And I said didn't I tell you that story?
No.
About me rappelling? No? Oh, well. It's probably because I was mad at you guys because you're talking too much and I didn't tell you the story. So that's what you get. But I told a real funny story about rappelling. Go to my honors class, 7th period, when I talk about slope. You can hear my story about rappelling. I even draw nice little pictures of me falling down a cliff. Actually, I didn't fall down. I almost fell down. But anyway, so it's a vertical line. So if it's undefined, it's a vertical line. Okay, we did talk about skiing, though, didn't we? You'll never go to a ski slope and actually see something that goes completely straight up and down. All right? Right, you can't jump off a cliff. I mean, you can jump off a cliff, I guess, but you're not going to survive. What will be left of you at the bottom? You'll be undefined, won't you? Okay, so this is undefined, or you could say no slope. That's a lot different than this. Can you go skiing on a slope like this?
Yes.
Absolutely. Okay, you can ski on a slope like this. You won't go very fast. You got to push, but you'll slide, right? So yeah, you can go on this. Shh, listen. But can you ski on something like this? No, you cannot. You will fall, okay? You'll be flying. You will not be skiing anymore if you go down something like this. So this does not exist, all right? You'll never see a sign that says, oh, go this way. This is 12 black diamonds. Okay, if you know anything about skiing, if you go to 2 black diamonds, that's really, really high, double black diamond, okay? So it doesn't matter how many black diamonds you put on it, this will never be a slope that you're supposed to go skiing down, all right? So this is what? No slope. Same thing as undefined. Do not put 0. If you put equals 0, I'm marking it wrong. If you circle this, and don't write anything else after it, I'm marking that wrong. Have I made myself clear on these? Yeah. I hope so. Very clear. So if I get complaints on it, I'll point you back to this and say, look, I recorded it. I told you you couldn't do this. Now, let's do some more stuff with slope. And we are going to do this. Let's write this down. I will put the points after it because the points on this one are important. B. Manny, please. M is negative 8.3. And one more, V is negative 4.2. All right, here's the question. It says, let's compare these two lines because this BT is actually a line. If I plot that, it's 2 points, connect them, I'd get a line. Let's compare that line to MV. Right? Now, you don't have to plot these things out. That's the nice thing about this. You don't have to graph it and look at it. And I had a lot of, I always say a lot, but I had a few people, plot this out on a graph and looked at it and that kind of stuff. That's not what you want to do. Okay? It's easier than that, to tell you the truth. I want to find if these two lines are parallel to each other. I want to find out if they're perpendicular to each other, or I want to find out if they're neither one. Okay? If they're neither perpendicular nor parallel. Do you remember about parallel? What is true about the slopes? If two lines are parallel to each other, what's true about the slopes? The slopes are exactly the same. All right, so if I look at the slopes of these two and they're the same, then the two lines would be parallel. What about perpendicular? That's right. So if the two lines are perpendicular, the slopes are negative reciprocals of each other. So that's what we're going to do. We're going to find the slope of BT. We're going to find the slope of MV, and then we're going to compare the two slopes. If they're the same, it's parallel. If they're negative reciprocals, it's perpendicular. If none of those things are true, it's neither. Does that make any sense? So let's find BT, the slope of BT. Well, here's B and here's T. Let's find the slope. We've done this, what, 3 times already. 3 times already. This is our 4th time. So let's find the slope. Subtract the y's, negative 4 minus 12. Subtract the x's, 1 minus 5. And that's what? Negative 16, right? Over negative 4. That simplifies to be a 4. So the slope of BT is 4. Now what do we have to find the slope of? MV. So let's find the slope of MV. M means slope of MV. Here's M and V. Let's do that. Subtract the y's, so it's 3 minus 2. Subtract the x's, so it's negative 8 minus negative 4. What's minus and negative, though? It's plus. 3 minus 2 is 1. Negative 8 plus 4 is negative 4. So let's take a look at our two slopes. Here's one slope. Here's another slope. Is there any type of relationship between these slopes right here? They're negative reciprocals, aren't they? Okay, because look, if I flip 4, if I take the reciprocal of 4, it's 1/4. If I take the opposite sign, it's negative. Yep, they're negative reciprocals of each other. So Sean, tell me, what are these two slopes then? Or these two lines? They are what? Perpendicular. That's right. So I could just write the word perpendicular here. Yeah, you're the last one. Nobody else leaves after this. Perpendicular. All right, so you can just write perpendicular, or if you want to put the perpendicular symbol, you could do that as well. It's probably better if you just write the word perpendicular. That's all there is to it. Now look, you got a 1 in 3 shot to get this problem right, don't you? You could say perpendicular, you could guess and say parallel, or you could guess and say neither. But I'd rather have a 100% chance, wouldn't you, than a 33 1/3% chance, a 1/3% chance. Okay, so make sure you know how to do that. Now let's take a look at number 9. Number 9 is pretty much the same deal. I'll do this in a different color, keep it right here. So number 9, actually I'm gonna have to scooch it down because they give you different points. So let's do this really quick. I'll try. So negative 5, negative 7. T is 1017. M is negative 5, negative 10. And V is 5, 6. All right, so let's find BT, the slope of BT. So let's do this. This is what, the 5th time now we've done slope. All right, so this should be really pretty straightforward now for you. So we subtract the y's, negative 7 minus 17. We subtract the x's, negative 5 minus 10. Let's figure out what that is. That's negative what? 24 over negative 15. Yeah. Negative over negative is positive. What divides in evenly into both of these? 3 does. 3 goes into this what? 8 times. 3 goes into this 5 times. So that's 8 over 5. So that's the slope of BT. Let's find the slope of MV now. So we do the slope, same thing. So it's negative 10 minus 6, and it's negative 5 minus 5. Let's see what we get. We get negative 16 over negative 10. Let's reduce that. That's positive. And what? 2 goes into that, right? 8 times. 2 goes into that 5 times, so we get 8 over 5. Is there a relationship between these two slopes right here? Absolutely, they're equal to each other. So what kind of a line, or what kind of lines are these two lines to each other? They are parallel, that's right. So if they're equal to each other, if the slopes are equal to each other, then the lines are parallel. All right? I think we've covered that plenty. All right, now is where we're getting to the stuff that's a little bit tougher. This is definitely Algebra 2 stuff. I mean, it's Algebra 1 stuff, to tell you the truth. We do it in geometry, we do it in Algebra 1, we do it in geometry, and you also do a lot of this in Algebra 2. So here is number 10. It says, write the equation in point-slope form. Well, first of all, you need to know point-slope form. And again, I haven't done this yet, but I think I might put this on the review sheet thing. Okay, so point-slope form is this. But you got to know what the stuff means. Okay, I'm not going to sit there and explain everything to you. I'll give you the formulas, but you're going to have to know how to use the formulas and what the formulas mean. All right. So this is the point-slope form. I'll put form right there. And this comes in really handy from time to time. Let's look what they give us. They give us the slope. They say the slope is negative 3 over 2. And they give us a point, which is 7, negative 3. And that's kind of nice. Giving us a point and a slope, right? Because we've got the formula right here, point-slope form. So you got to know what to do with this stuff. Well, what do you think? The m's pretty obvious. Where are you going to put the m? Right in there, okay? What about this 7 and the negative 3? Where are they going to go? 7 goes into the x1, right? Not the x, but the x1. And then the negative 3 goes in for what? The y1. Everybody got that? Okay, so the x and the y, without the 1 next to it, they just stay x and y. So let's plug stuff in. So it's y minus y1. What's our y1? It's negative 3. What's minus and negative? Plus. Don't leave it minus and negative. All right? Make it a plus. All right? Again, a pet peeve of mine. Make it a plus. Don't leave it minus and negative. Equals m. What's our m? Negative 3 over 2. It's right there. Times, parentheses, x minus x1. What's our x1? 7. And that's it. You're done right there. That's your answer. You don't have to simplify it. You don't have to get y by itself. You don't have to do any of that stuff. You just leave it like that. Why? Because they ask you to put it in point-slope form. And that is in point-slope form. Pretty simple, isn't it? I think so. I get accused all the time of saying everything we do is simple and easy. But you got to agree with me on this one. That is pretty simple, though, isn't it? Okay. Let's take a look at number 11. This one says, and the rest of them, 11 through 15, all say what kind of form? Slope-intercept. So you need to know which one is slope-intercept form. Slope-intercept form. Now you should have this thing memorized, for goodness sakes. But if you don't, I'll probably have it on your little formula sheet thing. So what is a slope-intercept form, though? It's y equals what? Yeah, that should be memorized, okay? You should never, ever forget that. Y equals mx plus b. We use it so much. So let's look what they give us. Number 11. They give us a slope again. I'll write it right here. They give us a slope, and they give us a point. Now, I did this in my honors class yesterday. When I taught this before, we threw all this stuff into slope-intercept form. But since we just talked about that point-slope form, so everybody listen now. Since I talked about this point-slope form, I got a point and I got a slope. Watch this. This might be a little easier for you. Let's actually put this into point-slope form. I know it says write the answer in slope-intercept form, but since they gave us a point and since they gave us a slope, it might be a good idea if we use that point slope form. All right, so let's do that. So it's y minus y1. What's our y1? It's -6. Sean, please. Is that true? It's okay. You don't hear that? Okay, but it's still doing it. Okay. So equals m. What's our m? 3 times x minus x1, which is -5. Let's turn that into plus as well. Now look, that's not my answer because that's not slope-intercept form. But if you watch, it's actually really easy to put this in a slope-intercept form. What am I going to have to do to put this in a slope-intercept form? Just going to have to do what? Solve for y, right? I'm going to have to just solve for y. So let's do that. It's actually a little easier than what I showed you before. So it's y plus 6 equals. What are we going to do with this 3? Yeah, give me a word. Give me one math word here. Distribute. Thank you. So it's 3x plus 15. Watch this. One more step. Subtract a 6 from both sides. And y equals 3x plus 9. And there's your answer. That was pretty easy, wasn't it? So since they gave you a point, and since they gave you a slope, I thought it was pretty easy just to put it into the point slope form. But then you can't keep it like that, though. Okay? You cannot keep it like this because the question said write the answer in slope-intercept form. Everybody getting this? All right. So there you go. Y equals 3x plus 9. Let's do another one. You got some time? We're moving right along here, aren't we? That was 11, right? Let's do number 12. Let's take a look at 12. This time they give you 2 points. We're not finished yet. Let's everybody stay with me here. They give you 2 points, 2, -4, and 5, 8. And they ask you to write this, write the equation of a line. They ask you to write the equation of a line in slope-intercept form again. All right, so our answer needs to look like this, y equals mx plus b. That's slope-intercept form. Well, look, this time they didn't give me 1 point and 1 slope. They gave me what? 2 points. So what do you think I'm going to have to find? Find the slope. That's right. We've done the slope like 6 or 7 times already just today. We've done slope. So let's find the slope. So the slope, changing y, we're changing x. -4 minus 8 over 2 minus 5. Everybody you should be able to do that in your sleep practically. So it's -12 over -3. Always simplify it, and that's a +4. So our slope is +4. You look like you're going to go right back to talking as soon as I start. You just look like it. Okay. So let's take a look at this. If you want, you could put the stuff back into the slope-intercept form, but since we did that point-slope form, I kind of like that way. So let's do point-slope form. Y minus y1. Now, which point do we pick? We got 2 points. Does it matter which one we pick? Nope, doesn't matter. Okay, you could pick either one of these. Which one would you rather pick? Yeah, most people say 5, 8. Why would you say 5, 8 instead of this? Because they're both positive. That's usually a little bit easier. So let's do that. So it's y minus y1, which is 8, equals m. Well, we just found the m, didn't we? Times x minus x1. And now, what do you have to do? Just get y by itself, and then you're done. See how easy this is? 4x minus 20. One more step and you're finished. Just add an 8 to both sides. And y equals 4x minus 12. And that's your answer right there. So again, what did we do? We had to find the slope first, okay, because you got to put it into slope-intercept form. So we had to find the slope. That was easy. We did that about 6, 7 times today already. And so we found the slope. Now, if you wanted to, you could take one of these points and put it in for this x and this y, put in the slope, and then solve for b, and then put it all together. I think this way is a little bit easier. Using that point-slope form comes in handy. So if you know the point-slope form, I think this works out real nice and easy. All right? That was number 12. I'll tell you what. Yeah, I'll be rushing if I try to finish that in this class. So that means, what am I going to do? I'm going to do number 13 to 20 in where? In the 5th period class. So if you want to see how to do 13 to 20, And I'm telling you, don't just blow this off. Don't just use the time we have in class. I really, really encourage you to go to the videos. Go to the YouTube video for 5th period. It'll be on your, it's under your section, under your playlist section. It'll say 5 in front of it, but it'll say like part B. All right, but 13 to 20 will be on there because that's what I'm going to do 5th period today. So make sure you look at it and you know how to do those problems.